Talking about slope of a line today, and this one is a really, really important topic. You've probably discussed it before in one of your previous classes. It's pretty simple on the surface of what it is, like the basic idea. You go from one point to another on a graph, and you find out how fast are the y values changing with respect to the x values. And I guess really it's just how fast what's the change in the y over the change in x. And so if I went from, say, this point here, we went up to there and then over to get to this next point here, our change in y, that's this, and we use this little Greek letter delta, so that's the change in y, and then this is the change in x. And so the way we write our slope, it's always a ratio, and it is always we represent it with the letter m, and m is equal to, and a lot of the times you'll hear rise over run, so that's your ratio that we use to get our slope. Also, I'm going to refer to it a lot as the change in y over the change in x. So how much are your y's changing with respect to your x's? Now what's cool about this is when you're finding the slope, it doesn't matter what 2 points you use on a line to calculate your slope. You'll always get the same thing. So for this one, I went from this point to that point, and so we went up 1, 2, 3, so that was our change in y, and then we went over 1, 2. So this one has a slope of 3 to 2. Now we should get that no matter what, because it's a line. The slope is it's going to be the same. It's a constant slope no matter where you are on that line. So if we went from, say, this point to this point, let's look at that change, and we'll do that one in green. So we would go up like this, and then we stop there because we stop at this location because now we're level with this point here. We're on the same x value. And so now we just move in the x direction, and we go to the right. And so we'll count that off. Let's see what we get. So we start here, we're going to go up 1, 2, 3, 4, 5, 6. So that one, the slope for this one is 6. And then 6 over, and then our change in x, that's going to be 1, 2, 3, 4. So 6 to 4. And if we simplify that, we get 3 to 2, which matches the first one that we found. And that's true for any 2 points that we decide to choose. If we did from here to there, we would get just an equivalent ratio to 3 to 2. And also, it doesn't matter which direction we go. So if we've been going from here to here, let's go from, say, here to here. So that means our slope is going to look like this. We'll go from here, we're going to go down till we reach there, and then we're going to go this way. And so for the slope, the calculation, this in the yellow, we're going to go from here, we're going down 1, 2, 3, 4, 5, 6, 7, 8, 9. Now that's 9 units in the negative y direction, so that's going to be negative 9. So before, we were always going up, which is always in the positive y direction, and then to the right, which is always in the positive x direction. Well, now we're going down, that's the negative y direction, and then we're going to go to the left, which is the negative x direction. So we would go 1, 2, 3, 4, 5, 6, and that's negative 6. And if you simplify negative 9 to negative 6, that's negative to a negative, that's going to be a positive, and then it's 9 to 6, that simplifies 3 to 2. So you still get the same as before. Okay, now we want to also be able to calculate the slope if we're given 2 points, like this one, 5, 4, and this point here, 3, 1. This is the same line as our previous example, and we already know that it's up 3 over 2. So we know the slope is 3 to 2. We just want to be able to calculate it if we're just given 2 points and we're actually not given the graph. And because you don't always want to have to to draw the graph, and we can calculate it. So let's look at how we would calculate it. And so let's just start by looking at this 5, 4. The distance that for that point, the distance from the x-axis is 4 units, and that's given by the y value here of 4. So that tells you how far away you are from the x-axis. That's 4 units up to get to here. And then similarly, with the 3, 1 point, which is the lower point, the distance it is from the x-axis is given by this distance, which is 1. And so if we know that this is 1 unit up and this one is 4 units up, we want to find out the distance between these 2 points in the y direction. So we're just focusing on the y's right now. And that distance is from here up to there, okay? And so that's always going to be 1. That's, in this case, it's going to be 3. And we can get that using this 4 and this 1, because if we subtract this distance away from this distance, we'll get what's in between, which is this distance, and that's what we're trying to find. And that distance is the change in y. And so it's really just the difference between our y values to get our change in y. And so that's where we get y2 minus y1. And maybe before I do that, let me erase that. And I'll just, for now, I'll put 4 minus 1. So that's our change in y. Now our change in x, we could do this similar thing. We would look at how far away we are from the x-axis. I'm not going to go into too much detail with that one because we've already got that. The idea of getting that change in y and change in x. Whoops. So our change in x is that little distance there. And that, in this case, would be 5 minus 3. Okay, and then what we get is 3 to 2. Okay. Now, if we wanted to, we could change the points. So we would have this one here we could call x1, x sub 1, y sub 1, and then this one we could call x sub 2, y sub 2, and all those little, the ones here and the 2 here and here, those are not powers. Those are, notice those are below the x and the y. These are just little subnotes, and they're just, they just give you a little, it's like notation telling you this is the x value from point 1, this is the y value from point 1, this is the x value from point 2, this is the y value from point 2. So this is point 2, and this is point 1, and point 2, point 1. And so what we can do is write our slope equation, which is always going to be y2 minus y1, x2 minus x1. And it doesn't matter which point you choose to be point 2 and point 1. This could be point 2 and this could be point 1. Doesn't matter. What really matters and what's really important is that if you choose a point to be y2, or excuse me, if you choose a point to be point number 2, then its y value will go first, and its x value will go first down here. That you just have to be consistent. The y value from the second point goes here, and the x value from the second point goes here, and then similarly the y value from the first point goes here, and the x value from the first point goes here. So this is our slope equation. And we can use that to calculate slope if we're given any 2 points along a line. So we're going to determine the slope of this line that's shown here. So first I just need to, if you have a graph, you can just count it off. And that's usually easier than anything else. So I just need to go through and find a point that's on this line. There's a point on this line, and here's a point on this line. So I would go from here, remember the slope is going to be m equals, and you can think of it as rise over run. Again, you can think of it as the change in y over the change in x. So I am going to go from here to get to this point here. I'm going to go down 1. So my change in y is going to be -1. And then once I go down that 1, now I'm going to go over to the right. 1, 2, 3, 4. Now to the right is positive x direction, so I'm going to go over 4. So the slope of that line is -1 to 4. I could also, had I chosen to go from here to here, I could do start by going up 1. So that would just be 1 over, and then I would go from here, I'd go up 1, and then to the left, 1, 2, 3, 4. And so that would be, to the left is negative, so that'd be -4. These slopes are equivalent. Okay, that's -1/4. And y, whoa. All right, here's a couple of, there's 2 lines. We're going to find the slope of both of them. So the first one, remember, slope is equal to the change in y over the change in x. And let's just go from, say, this point to this point over here. So the amount that we're going to change in the y direction to get from here to there is 0. And then the amount we're going to change, I think I chose this point, we're going to go over 1, 2, 3, 4 units to the right. That's +4. So this is 0. This has a slope of 0. And if you look at this, no matter where you are on this line, you're never going to go up or down to get to the next point or to get to another point. And so our change in the y is always going to be 0. And this is just a flat line. It has a slope of 0. The other one, so we got the change in y over the change in x. If we go from, say, this point to this point, we're going to go up 1, 2, 3, 4. So up 4. And then from here up to there, that's going to be 1, 2, 3, 4 units up. And then we're not going to go in the x direction at all. So we're moving 0 units in the x direction. And anything divided by 0 is going to be undefined. So the slope of a vertical line is undefined. So a horizontal line has a slope of 0, and a vertical line has a slope that is undefined. Okay? So keep that in mind when you're working. Last one. This one, we don't even have a graph. We're just given 2 points, and we're asked to find the slope. So I forgot to write that. So determine the slope. So what we're going to do is, remember, the slope is equal to the change in y over the change in x. And the slope equation is y2 minus y1 over x2 minus x1. And so I think I'm going to choose, and you don't have to do this always, but I'm going to choose this point on the right to be my point number 2, and the point on the left to be point number 1. So that would mean this is x2, this is y2, this is x1, and this is y1. And so now I can just fill in what I've got. So y2 is 9, y1 is 5. And then remember, I started with the y value from this point here. So I have to start with its x value, right? So 9 is here, so that means its corresponding x value is going to be down here. So that's going to be x2 is 4, and then x1 is 3. And that's going to give us 4 to 1. So the slope of the line that passes through the 0.35 and the 0.49 is going to be 4. And even if I had switched this, so this was point number 2 and this was point number 1, that's totally fine. You would get m is equal to, again, change in y over change in x. And so I would have 5 minus 9 over 3 minus 4. I'd get -4 over -1. Still, that's 4 to 1. It's positive. Okay? So it doesn't really matter which one you choose to be 0.2 and which one you choose to be 0.1. You'll get the same slope. I know I said that the last slide was the last one. This is the last one. Okay, and this will be quick. So we're going to graph the line that passes through the given point, so this point here, and it has the given slope, so it has this point. So we're going to graph it. So start by just graphing the 0.34. So 1, 2, 3, 4. So that's right here. So there's our point. And then we have to have a slope of -1 to 2. So I'm going to go down 1. and to the right 2. So that will get me to that point there. So this is another point on our line. And then I can also, remember, slopes, this could also be written as 1 over -2. So I could also go up 1 and to the left 2. So I could go up 1 and to the left 2. And so that will get us here. And so now we have 3 points very quickly. And so we can graph this line. It'll go just like that. And we're done. Okay?